First of all, a big thank you to the organizers at Climate Change AI for inviting me and for all their hard work in putting this event together. Today, I'll be speaking about the energy and climate impacts of digital technologies, drawing on our work at the IEA and all the great research being conducted by colleagues all around the world. First, a bit of context on where we are today in terms of our greenhouse gas emissions and where we need to go. Some of you might already be familiar with charts like this one, which show just how quickly emissions have grown over the past few decades. This one shows carbon emissions from the energy sector. This includes everything from oil and gas production to electricity generation to the energy used in transportation, buildings, and industries. These are all the sectors that we cover at the IEA. This year, carbon emissions are expected to fall by around 7% because of the COVID crisis, or around 2.5 billion tons, which would be the biggest annual drop in history. But what's really daunting is that emissions need to fall at almost this pace every year for the coming decades for us to reach our climate goals. For around 1.5 degrees, that means net zero by 2050. And for around 1.7 degrees, that's net zero by 2070. That means we need big structural changes to policies and infrastructure, since the kind of behavioral and economic changes we saw in 2020 just aren't sustainable and came at an incredible cost to human life and to society. With government spending trillions in recovery packages, we really are at a critical turning point. If governments invest in clean energy, we still have a chance at a 1.5 degree world. But if they choose to invest in polluting technologies and industries, emissions are likely to bounce back, like we've seen after other drops in the past, and our chances at even a 2 degree world could slip away. So you might be wondering which sectors and activities are most responsible for greenhouse gas emissions. About 3/4 come from the energy sector and industrial processes. The rest come from agriculture, forestry, land use, and waste. Within the energy sector, emissions come from many different sectors and services that use fossil fuels. Industries, buildings, transportation, coal and gas power, and fossil fuel production. Now, with that bit of background, let's focus on digital technologies and how they impact the climate. Digital technologies have a very real carbon footprint, from the energy used to power the data centers, data networks, computers, and smartphones that we use every day. And how they're used affect emissions from other sectors. For example, how GPS and smartphones have enabled new transport services like Uber and Lyft. And in turn, these changes can have secondary effects on other sectors and services and our built environment. Let's first look at the direct energy use and emissions from digital technologies. One thing about digital technologies is that they're growing very quickly compared to other economic and energy indicators. Since 2000, our population has grown by around 1/4. GDP has almost doubled. Electricity use is up almost 70%, while the number of internet users has grown by more than 10 times. And global internet traffic has grown by more than 2,000 times. So it kind of makes sense that there's growing concern over the energy and environmental impacts of digital technologies. Here's a headline from The Guardian a couple of years ago saying that a tsunami of data could use 1/5 of global electricity by 2025. And these kinds of headlines have been around for a long time. Here's one from 1999 that predicted that the internet would use half the US electricity supply by 2010. And for that reason, the article argued that the US should build more coal-fired power plants. But in reality, the latest research shows that energy use and emissions from the ICT sector have actually been flat over the past decade. Researchers in the US published this paper in Science earlier this year showing how global data center energy use has been flat since 2010. Since 2010, internet traffic is up 12 times, and demand for data center services is up 7.5 times. But data center energy use has been flat at around 200 terawatt hours, which is around 1% of global electricity use. Data transmission networks use another 1%. There are really two main drivers that explain how data demand and energy use trends have diverged. First, the energy efficiency of computing and data transmission has been doubling every 2 to 3 years. And for data centers, there's also been a massive shift from smaller, less efficient corporate data centers to much more efficient cloud and hyperscale data centers. And these big data centers are getting even more efficient. A few years ago, DeepMind applied machine learning to cut energy use for cooling by 40%. So the industry is doing a lot in terms of energy efficiency to reduce the energy that it needs. It's also doing a lot to make sure that the remaining energy needs are supplied with clean electricity. The big tech companies are the biggest corporate buyers of renewable electricity in the world. Apple and Google have reached 100% renewables for a few years now, and Facebook is expected to reach 100% renewables later this year. What that means is that they're buying enough renewable energy each year to match the amount of electricity that they're using in their operations. So for every terawatt hour of electricity that they're using, they're buying a terawatt hour of renewables. But that doesn't mean that their operations are fully powered by renewables all the time. Data centers run 24 hours a day, but solar and wind aren't available all the time. That means that they still need to rely at least some of the time on the grid, and that it means it really depends on where they operate. You can see on this map from Google that some of their sites, like in Oklahoma, run almost exclusively on clean electricity. But in other places like Singapore, it's mostly gas. Overall, they've estimated that they're at around 60% clean energy on an hourly basis. Google recently announced that they're aiming to get to 100% carbon-free electricity 24/7 by 2030. That means they'll need to get enough zero carbon electricity at each site for every hour of the year. That might mean using machine learning to better forecast when and where renewables will be available so that they can shift some workloads to different times of the day, or even different sites to take advantage of renewables being generated. So far, we focused mostly on the use phase of digital technologies, but there are impacts throughout the life cycle of all products, from raw materials extraction and manufacturing all the way to end of life. For smartphones, for example, the use phase is actually a small part of its overall environmental impact. Around 80% comes from material extraction in the manufacturing phases. And there are some other environmental impacts beyond energy use and greenhouse gas emissions, like impacts on land, air, water, biodiversity, and of course, electronic waste. So we've talked a bit about data centers, networks, and devices, but what are the specific impacts of individual digital activities? You might have seen headlines like this one over the past year, which said that watching a half-hour show emits as much CO2 as 4 miles of driving. It turns out the numbers in those headlines were 40 to 80 times too high. Of course, the numbers depend on how your electricity is generated and whether you're watching on a big screen TV or a smartphone, since a big TV uses about 100 times more electricity than a phone. But on average, a half-hour show probably emits around 20 grams of CO2, which is around the same as driving 100 meters in a combustion engine car. The main takeaway here is that emissions from streaming video are actually very small compared to other everyday activities, and definitely much lower than driving to a movie theater or buying or renting a DVD. But of course, it's become a lot easier to watch more, so there's a big rebound effect we also need to take into account. So going back to this, could this headline actually come true over the next 5 years? That number actually comes from a 2015 study that estimated ICT energy use and emissions out to 2030. The big challenge with long-term energy projections for digital technologies is that the technologies and their uses change quickly, and they're very hard to predict. That same author's latest projections published this year are 4 times lower than his original projections that were quoted in The Guardian. In just the past 10 years, we've seen smartphones become mainstream, new generations of mobile networks, much more streaming media, and huge efficiency improvements to keep energy demand in check. And now we're seeing emerging technologies like blockchain, machine learning, and 5G And it's really hard to predict how new applications that are built on top of these technologies could impact data demand and energy use in 10, 20, or even 30 years. Let's shift gears a bit and talk about some of the effects that digital technologies could have on other sectors. A good example here is teleworking, something more people are doing these days because of COVID. Generally, the direct energy use of digital technologies is about the same whether you're at home or in the office. So most of the net effects are actually going to come from using more energy at home for heating or cooling, offset by energy saved from not commuting. The net effects really depend on your situation. If you live in a big home and it's wintertime, you're probably going to use a lot of energy for heating. And the amount of energy you save from not commuting will depend on how far you travel and whether you drive, take public transit, or walk or cycle. And whether the office saves energy really depends on how often you telework. Because an office that's half full is still going to be using a lot of energy to keep it running. There are also longer term effects that are difficult to predict. Somebody that can telework all the time might choose to move outside the city where houses are cheaper to buy. And that might mean that they can buy a bigger home or get a car, which means they're probably going to be using more energy overall. Well, the net effects of day-to-day teleworking really depend on the situation. One thing that's for sure is that replacing a business flight with video conferencing can save a lot of energy and emissions. A couple of years ago, we published a report looking at how digitalization could impact the energy sector. We found a whole range of applications that could cut costs, improve efficiency, and help reduce emissions. In buildings, these are things like smart building controls and thermostats that can help optimize energy use. In transport, we looked at automated vehicles and how they could slash energy use if they're shared and electric, but could also drastically increase energy use and emissions if they displace public transport and are not shared or electric. In industry, we looked at how 3D printing and digital twins could accelerate innovation and reduce material and energy use. In electricity, sensors and automation are already being used to improve efficiency and reduce maintenance costs. Machine learning is being applied to forecast solar and wind and better match supply and demand from increasingly decentralized sources. And in oil and gas, I just saw a paper published the other day that applied machine learning to cut the costs of detecting methane leaks. I think it's worth highlighting here that how digital technologies are applied in these sectors will really be shaped by climate policy. It's important to remind ourselves that digital technologies are agnostic to climate. While we hope that they're applied only to reduce emissions, they could just as easily be applied to increase emissions, like through extending the lifetime of coal plants or accelerating the extraction of oil and gas. What we need are strong climate policies to make sure that digitalization helps to combat climate change and not make it worse. Before I wrap up, I just want to highlight a couple key points about the challenge ahead for decarbonizing the energy system. First is that emissions today come from many different sources. And that means we can't pick and choose which sectors to decarbonize or which clean energy technologies to use, because we need to use all of them to decarbonize all sectors as quickly as possible. And the challenge with the energy sector is that energy infrastructure lasts for a long time, especially when we compare them to digital infrastructure and hardware. Coal-fired power plants have a lifetime of more than 50 years. And that means a coal plant that's being built today in Asia could still be running in 2070. A new gasoline car that's coming off the assembly line could be driving around in 20 years. The other point is that while dealing with existing assets, we also need to rapidly scale up existing and new clean energy technologies. This is an area where I think digital technologies could play a huge role in accelerating innovation cycles with technologies like machine learning and digital twins. To reach net zero by 2070, about a third of emission reductions will come from technologies that aren't yet commercial today. And to get to net zero by 2050, almost half of the emission reductions come from these technologies. And for hard to abate sectors like heavy industry and long distance transport, 3/4 of the reductions come from these early stage technologies. So to wrap it up, there's a lot we can do as individuals, researchers, and practitioners to reduce the carbon footprint of our digital activities. But there's even more that governments can do with strong, enabling climate policies to make sure that digital technologies help to accelerate climate action. As individuals, we can replace our devices less frequently and watch our shows on smaller screens when we can. And there's a lot we can do with our transport choices, especially flying, and of course, our diets. But I think the most important thing we can do as citizens is to support climate champions, whether that's through voting, supporting NGOs, or buying from responsible companies. As ML practitioners and engineers, there's a lot you can do in your day-to-day work, both in terms of reducing your own emissions, but also figuring out how your skills could help tackle climate change in other sectors. Governments perhaps have the biggest role to play through ambitious and concrete action on climate change that encourages tech for good. And finally, there's a lot that tech companies can do, not just reducing their own emissions from their data centers and products, but figuring out how to use their cutting edge technologies and vast resources to accelerate the global clean energy transition. There's a lot of potential for digital technologies to help tackle the climate crisis, and we need everyone, citizens, experts, companies, and governments to do their part to help ensure a more sustainable future. Thank you.